Yes. Yeah. It's great. Thank you. So before going to start, I will give you some quick points. And first thing is my voice is clear. That is very happy to hear. And this session is regarding to machine learning operations, that is MLOps. So this session is both theory and practicals. Okay, theory and practical. Practical about end-to-end flow. End-to-end flow of MLOps. MLOps. So that is the first thing. It is a both includes theory as well as practicals. And this session is about 2 hours. I'm expecting for 2 hours. It might be good for 2.5 hours also, because this is a very, very important topic. We need to connect with cloud and we need to showcase that how it is works. And I will take all the question and answers. I will give some pass in middle as well as at the end. So all Q&A session you can take at end. Most probably you can note your questions. I will give each and every one answers. Okay. And first of all, I need one confirmation. How many of you know about data science and machine learning? Yeah, 3 participants raise hand, 4, 5. Yeah, it's a good number of people are knows. That's very appreciate that. But this session is entire from scratch level. Okay, so I will go with scratch from to understand high level flow. That means both technical and non-technical people can understand. I can say that. So this session is from scratch. From scratch. Those who don't know about machine learning, also, they can now understand at least what is machine learning. Those who already know about machine learning, they know about what is ML operations, how it is working exactly. So that is our end goal. So there are two phase of candidates I'm seeing here. One knows ML and one don't know about ML. But don't worry, I will give from scratch level understanding. You can understand easily in the both levels. So coming to the myself, I am Omkar Nalagoni. Currently working as a senior data scientist. Senior data scientist with Accenture. So I have total 7+ years experience in IT trainings, and trainings. And this 7+ years experience completely relevant in data science and MLOps and some part of data engineering also. That is the cloud operations, everything. And I have completed my PG diploma in data science from IIT Tirupati. As well as I have a certified GCP ML engineering. And I have a certified in the Stanford University deep learning course. So I can say it is a deep learning course, that is a CS 232 course ID is. So that's all myself. So we will quickly go to our session now. Yeah. It's okay. Even though if you are a Java student, if you are not a IT background student, this will understand. That is not an issue, Pawan. Yeah, this I will go from very scratch level. I'm just sharing my screen here. And today our topics to be covered is what is machine learning, because what is machine learning we are using, and what is the types of machine learning, data science of life cycle, and after that what is MLOps, why we use MLOps, MLOps end-to-end workflow, and finally we will implement practical implementation of MLOps using MLflow. Okay, why we are going for machine learning, types of machine learning data sciences? Here there are all type of candidates will be available. Some people know about data science, some people don't know about data science. So that's why bear with us, those who are already know about machine learning. Okay, so let's start the session. So first one, what is machine learning, why it is important? So in my case, I can say easily. So here I'm just going to the show presenter view. And just taskbars. Yeah. Data science and machine learning. Machine learning is a part of a data science. Okay, machine learning, deep learning, NLP is a part of data science. ML is a modern astrology. Modern astrology. I can proudly say this. Modern astrology. What you will do in astrology? In astrology, you will predict the future. You will predict the future, but without any evidence. Without any evidence. But data science and machine learning will predict the future. DS or ML in the shortcut. Data science is the DS. Machine learning is the ML. Will predict the future. Predict the future with evidence. With a solid evidence. With a solid evidence. I can say solid evidence. And this evidence comes from some mathematical algorithms. This evidence comes from mathematics algorithms. So those mathematical algorithms, we are saying machine learning algorithms. Simple. We are saying ML algorithms. Very simple. So machine learning is generally, it is to predict something by using mathematics. That's all. And that mathematics, based on that, we will develop so many ML algorithms. Like suppose, I will give one example. Okay. Provide me your company employees attrition at the previous history. Suppose you have a company called some Google company is there. Take that example. Now Google give me a data. There the previous employees history, those who are every year, those who are leaving the company. If you give me that data, I will analyze the patterns. And I will say in the next couple of the years, how many people, how many employees will stick with your company? How many employees stick with your company? Stick with your company. We can say that. Suppose you are a DMart owner. You want to identify your loyal customers. Give me customers transaction data. I can say, who are your loyal customers? I can say that. Suppose you are a bank manager. You want to identify whether a person can pay the loan or don't pay the loan. He can pay the loan or don't pay the loan. Give me your customers data, previous data. I can say easily he can pay the loan or don't pay the loan. These all are use cases. That you can predict the company future by using called machine learning. What machine learning will generally do? It will analyze the data, and patterns. It identifies some patterns, identify some patterns in the data, using mathematics, using math. So I will give one example. Everyone know the movie called Super 30, right? Super 30. That's the famous Anand Kumar biography. He's an IIT trainer. In that there is a scene called Hrithik Roshan. Hrithik Roshan went to a hotel. Okay. He will say to the hotel guy, your hotel will not run in next 2 years. Will not run in next 2 years. He will say that, if you remember that scene. Okay. Hrithik Roshan will went to the hotel and he will say, your hotel will not run in next 2 years. That hotel guy will shock how it is happened. Then Hrithik Roshan come up with some calculations. Okay, some mathematics. And then the hotel guy will believe. So that is the power of mathematics. If you say the statements, people will not convince with statements. People will convince with numbers. Numbers should talk, not statements. That is the beauty of data and analysis. People will convince with them. If I say Usain Bolt will 100 meters run, he can do in the 8 seconds. If I say that, you will not believe. But if I show the statistics of Usain Bolt, you can definitely believe. So that is the power of mathematics, and those we are implementing in the machine learning algorithm. But how this will happen? How this will happen? How this will happen? How this will happen? How the patterns are happening? How the patterns are happening? Everything, how they are thinking. Now everyone talking about AI, ML, deep learning, they're talking about that. How these patterns are happening. I will give one example. In our families, we have a kids is there, right? Small kids. You want to train your kid with some information. Train your kid with some information. What is the information? Example 1. Okay. Example 1. You are watching a TV. You are watching a TV. Okay. Now you say to your kid, this is a TV. This is a TV. Now, because the kid is a human being, he can understand what you say, and he will understand some patterns. What is the patterns? First pattern, it is a rectangular box. Second pattern, some colors are there. Obviously in the TV, some show is running, colors will be there, right? Some colors are there. And third point, some cartoon people are also there. You will understand the cartoons. You don't know about Shah Rukh Khan, you don't know about Salman Khan, who is coming in the TV, right? He will simply understand the cartoons. So these patterns he can understand. That means he understands the patterns. His nerve system is understanding the patterns. That is, we are talking about neurons nowadays in the deep learning. Now, second example. You went to the theater. Or mall to watch a movie. Now ask a question to your kid. Ask a question your kid. What is this? Now, based on his patterns, what is his patterns? Is rectangular box? Theater screen is a rectangular box? Yes. Some colors are going? Yes. Some cartoons are going? Yes. Then what is he'll say answer? He will say, Mama, this is a TV. Now you will say, no, it is wrong. It is not a TV. It is a theater. Then he will understand. He will add the fourth pattern. Okay, it's a big screen. Some big rectangular screen is there. Big rectangular screen is there. So that he will understand, okay, if it is a small rectangular box is there, it is a TV. If it is a big rectangular box is there, it is a theater. Now ask the third example. Now watch movie in laptop. Watch movie in laptop and ask the question, what is this? Now he already know about the small thing is TV and big thing is rectangular, that is the theater. He will neither say, because he is a human being, he can understand the pattern. He will neither say TV nor say theater, because he knows he is a human being. The same thing, how you are trained the information, how this guy is understanding the patterns. If that information you are testing with new data, now you are understanding whether he can say right answer or wrong answer. If it is say right, you are happy, your model is good. If it is wrong, again you are training with new data. So that's where the machine learning will applicable actually. So that's what is patterns, how our human being in mindset, we are discussing about patterns. In the same way, the mathematics also will discuss the patterns. The mathematics will generate the patterns. Now, if you see here, we are sending a trained data, we are creating some ML algorithm. The model is created. Now, in the same way, you are providing, you are a TV, you are providing a theater. Now you are asking a question, what is this? He might be predicted something. So that prediction you will do evaluate. Whether he say good, okay. If he say wrong, again you need to train with those data. So that way machine learning algorithms will works. I hope those who don't know about machine learning, now he can, some extent he can know about what is machine learning, right? Can I say yes or no in the chat? You can give me reply in the chat also. I can pass 1 minute. Yeah. Thank you. So next we have some types of learnings will be happened, because there is so much data is there, right? And the data is a huge data will be there. So that's why what they are doing, machine learning people, they are dividing some types. In that, one type is called supervised learning. And another type is called unsupervised learning. One more type is called reinforcement learning. It is very easy, guys. Supervised learning means, suppose you have a use case is there. In the use case, you have some input data is there and output data is there. So what is input data and what is output data? Now, coming to this bank data, suppose you go here. So this is a bank data. Some loan ID is there, some gender is there, education is there, self-employed, applicant income, loan amount term is there, and loan status is there. So what is the objective of this data? You need to identify the customer, whether we can grant a loan him or not. That is the objective. The objective is, so for this loan ID guy 1002, what is the status? Yes, you are granted a loan. For 1003 guy, you are not granted a loan. Okay, so these kind of data, if you see, that means these loan ID, gender, education, employed, these are, we can say, input columns. What we can say? Input columns. And what you are seeing loan status, we can say this is output column, because you want to predict something. So tomorrow I am going with my ID, I am a male candidate, I am a graduate, I am not a self-employed, and then my applicant income is there. So whether he can provide the loan or not. That means in the data, you have some input data will be there and output data will be there. If you see that kind of thing, we can say this is a supervised learning. We can say so. I have seen some participants are raise the hands, but I will pass in middle. You can ask your question in the chat at the time. I will definitely answer. Okay. Now next, Under the and now we got what is supervised learning here. So I'll just give an example here. Supervised learning. Supervised learning means you have some input data will be there, and corresponding we have output data will also be available, output data. But again, in the input data and output data, you have a supervised learning. In that supervised learning, again, we have one more technique is called classification technique. And second one is, we can say, regression technique. Classification, regression. What is the general English meaning of classification, guys? What is the general meaning of English classification? You are classified something. Okay. You are classification something like yes or no. Some zones, like suppose COVID zones. Nowadays, COVID zones, what is that? Green zone, orange zone, red zone, some classification. Some pass or fail. These are the classification. So here in the data here, loan status is Y is there and loan status is no is there. S is there, no is there. It is a classification. So first question is, do we have output data? Yes. Do we have output data? If thus output data is a categorical or not? Now next question is, if that output data is in the form of categorical, some English names, categorical, then it is called classification technique. Simple. So now I will a question, this is a supervised learning or not? This data is a supervised learning or not? Yes, it is a supervised learning. How can we are saying it has input data is there and it has output data also there? So it is a supervised learning. Next question, it is a classification problem or regression problem? Now check the output. If output is a categorical data or numerical data? Output is a categorical data, so it is a classification problem. Now one more example I will take. Now here my objective is predict the total number of sales based on the advertisement cost on different medium. I have a owner of some I am a owner of DMart. Okay, I want to increase my sales. So what I decided, I want to spend some money on some advertising. So I spend some money on TV and newspaper and social media. I want to predict my sales. If I spend this much, what is my sales? 2000. If I spend this much, what is my sales? It is a 1950. So first of all, do you identify the input here? What is your input columns here? TV, newspaper, social media. What is your output column? Sales. Now tell me, it is a supervised learning or not? Yes, it is a supervised learning. But if this your output is a numerical data or categorical data, it is a numerical data. Now output is a numerical data. So if it is a numerical data, then that model we call regression model. What is the model called? Regression model. So that is a supervised learning. That is the first one. And next one, if you see here, next one is called unsupervised learning. Unsupervised learning. So unsupervised learning is very simple, guys. Supervised learning, we are seeing some output data is there. In the unsupervised learning, we don't have output data. Very simple. We don't have output data. What is the example for that? Now see here. The example for this. This is called, the objective is segment or group the customers based on the annual income and spending source. Now you are a DMart owner. Now you have some customer IDs is there. Their age is there. their gender is there, and the annual income also there, and their spending scores. Every month, the customers are coming to your market and they are spending something money, and you are giving some spending score. Based on the spending score, you want to identify whether they are a rich customers or poor customers. They are important customers or not important customers. You want to group them. So here there is no output data. If our use case is, I want to segment the people. I want to divide the people. How many people are my rich customers? How many people are my poor customers? I want to divide those groups. So that's why it is called, it is a unsupervised learning. So that is the thing. And what you are seeing is called some algorithms. Like I said, machine learning is developed by mathematics. So that mathematics we are calling ML algorithms. So again, machine learning is divided to three parts: supervised and unsupervised. So under supervised, you have some classification problem is there, and you have regression problem is there. So classification means you have a output data, that is the step one. And next, that output data is categorical. Then go for these many algorithms: decision trees, Navi bias, SVM. Don't worry about these algorithms, okay? But just understand the high level view. Understand the high level view. First of all, machine learning is mathematics. Simple. I will give you a funny example. Now see here this. You have a data is there. When x is equal to 1, y is equal to 1, x is equal to y is equal to 4, x is equal to 3, y is equal to 9, x equal to 4, y is equal to 16. When I say x is equal to 20, what y is equal to? Tell me. What is the y is equal to? Put in your answer in the chart. I just want to see your, yeah, very good, 400. How did you say this 400? How did you say this 400? Because in your mind, you created some mathematics equation that is called y is equal to x square. This is ML algorithm, guys. This is a simple ML algorithm. Based on the previous data, you predicted one ML algorithm. Then you are sending this x is equal to 20 to this algorithm. It is giving y is equal to 400. Simple. That's it. Now think about, imagine as a big data is there. For the big data, you need some calculus and algebra mathematics. We will develop some mathematical equation like this. So those mathematical algorithms, we have given some names. That's all. But mathematics is very simple mathematics that we are using. That is algebra and calculus. Algebra and calculus. So only simple mathematics. We are not doing any integration and differentiation. That we are not using here. Simple algebra and calculus. We will develop some ML models. I hope people should understand now what is exactly ML model means. This is your history data. You created a ML model now. So now people already created some more ML models by using some mathematics. We are using that. Now these are the some unsupervised learning algorithms. Unsupervised learning algorithms. Don't worry about algorithms. Again, I'm saying that algorithms is nothing but some mathematics. Simple. Algorithms is nothing but a mathematics. Now coming to the reinforcement learning. Reinforcement learning is generally an agent. Agent should respond with our actions. Like iPhone Siri. Okay. iPhone Siri is there. Hey Siri, what is the time now? If you say us, it will give us some time. Right. So that is a reinforcement learning. So now robotics, self-driving cars, Alexa, these are the reinforcement learning algorithms. So that's why we call so I called AI nowadays. AI. Now if you see in 2019, I think in 2019 our ISRO do for Mangalyaan 2. Okay, that is for the moon. They actually should land at some place, but due to the environmental condition, it is landing some other place. That's why it is failed here. When it is landing, it is not able to landing successfully because the environmental conditions is not able to respond that agent. So they implemented the AI condition in the ISRO environment, but obviously in the moon conditions is different. Right? That is a rocket science. It's not an easy task. So that's why we got some failure, but it's 95% success, that is. So like that way, the reinforcement learning nowadays, the so much money they are spending on this reinforcement learning. So this is about the machine learning and the types, guys. So I will give one pass here. Okay. I will give one pass, and all the cluster algorithms are unsupervised ML algorithms. Yes, you are correct. All cluster algorithms are called unsupervised learning algorithms. Clustering nothing but grouping or segmentation. You are correct, Radesham. If you have any doubts, you can ask me. I will give 1 minute. We don't know cluster. What is one me? We don't know cluster. How to pursue this course? Yeah, this is a data science course. That will be talk about management. Okay. Yeah. Yes, that is an NareshIT. That is a management will talk about this, all these things. But at least you can identify the high level view, right? What is machine learning? What is data science? Everything. Yeah. Then you can easily learn about cluster algorithms. That is, that you can say. Yeah. Next, what is the reinforcement learning? Yeah, course content, that admin will take care of. Okay, that is not our workshop thing. Okay. Now, okay, we'll go to the next thing. That admin will take that. First, you understand the concept end-to-end flow. Again, at the end, we will discuss about your doubts. Okay. But in the middle, I want to know the specific questions that is related to your concepts. Now, some people are reinforcement learning algorithm they are asking. So reinforcement learning algorithms is completely AI algorithms. Okay. That is, you can know Hugging Face transformers. There's an example that is, we can say Hugging Face transformers or robotics transformers are there. There's a called Hugging Face transformers. Okay. Hugging Face. Hugging Face. Or you can say YOLO. There's a YOLO algorithm is there. You look only once. Okay. You look only once. You can test type YOLO. You will identify image objects for self-driving cars or moving objects. They will identify like this. There's some algorithms. So next, this is a very, very important, guys. What is a data science life cycle? What is a data science life cycle? So of course, I told you again, I learned mathematics, I learned everything. I want to implement the programming language I need required is Python. Okay. Those who are learning about Python, it is a very good course. Again, I'm saying that why this is Python is a tool. Python is a tool. Python is a tool, but data science is a subject. It is a subject. Okay. Cyber security. Cyber security is a subject. Okay. IoT. IoT is a subject. IoT is a subject like that. And cloud computing. Cloud computing is a subject. Okay. Cloud computing subject. Those who are learning the tools, my best advice is learn any one of the subjects so that you can master that subject, and there is so much lifespan in the IT career. Okay. Python is a tool. Those who are learning Python, the best choice is data science. That is end to end. You can know that. So next. So data science life cycle, guys. This is the data science life cycle. So any data science life cycle, not only any data science life cycle, guys. Suppose you are a data scientist. I am a customer. I am some HDFC bank. Okay. I am a HDFC bank customer. I want to know that my customer home loan capacity. So first and most important is what? You need to understand about business problem. Okay. First of all, what is your problem is the HDFC bank is coming to you and they will ask some help for you. Then first, what is that? You need to understand about business problem. What is your problem? Once you understand the problem, you need to collect the data. The HDFC Bank will provide data to you. HDFC Bank will provide the data to you. Next, this data might be a structured data or unstructured data. Data might be a structured data or unstructured data. So this data might be a structured way or unstructured way. Okay. Now what you will do, you will make a data preparation. You make the data into structured way, or you are putting into some database and ready to use. Some database, you will make into some database. You are load all this data to the in this database, and the data is ready. Once data is ready, this is the heart of data science, guys. We call EDA, exploratory data analysis. Exploratory data analysis. What you will do in the data analysis, you will understand some insights. Understand some insight. What is the insight? What is the mean value? What is the median value? What is the mode? What is the variance? How it is going? The all statistical concepts. What is the population? How the sample is working? And what is the hypothesis? These all are statistical concepts. If you remember your childhood days, we know our statistics, right? So based on the statistics, you need to identify, based on statistics, we need to identify some patterns. Identify some patterns. We need to identify that. So that's why EDA is a very, very important. And then once EDA is done, we will develop our ML models, so-called mathematics models, ML models. You said, sir, I created a model. Okay, you said, Omkar, sir, I created a model. But how can I know your model is good or not? How can you know your y is equal to x square is a good, correct model or not? You developed a y is equal to x square, and you said, sir, this is my model. Verify this. How can I verify? By using model evaluation. Whether your model is correct or wrong, I need to do the model evaluation. Then finally, your model is ready, and I need to deploy your model. Deploy means what? This HDFC Bank guy should use, right? You created your model here, but HDFC Bank guy should use. That is a model deployment. So this is the data science life cycle, guys. You need to understand the business problem, data collection, data preparation. It's a step by step. No need to by heart also. This is a common sense. I need to understand the problem. Next, I need to think about solution. For to think about solution, I need some resources. Here, resources is the data science. Now I have data is there. I need to prepare the data in the organized way. Data is prepared. I need to do some statistical analysis, because my duty is that data science duty is only to understand the patterns. Now I need to create a model. My model is done. Now I want to verify this model is good or not. That is the evaluation. Then I need to deploy the model, because HDFC Bank guys should use. Now data science is completed with this. Now you created a model. Now you created a model. Think like this. You created a model. I will take y is equal to x square only, because that you created from your mind just now. Okay. I'm just kidding, but y is equal to x square, your model, you created that model. Y is equal to x square. Now HDFC Bank should use that model. HDFC Bank should use that model. Okay. This y is equal to x square, you created a model by using Python code. By using Python code. You created by using Python code. Now Python code you run in your local. Python code you run in your local. Now how can HDFC guy use that? How can HDFC guy use your model? That is the question number one. Question number one, how can a client, we can call client, use your model? So this, we are in IT industry, the term called production. Okay, what with the term is called production. How can a client use your model in the production level? How can a client use your model in the production level? And second question, the client is saying that every month I will generate a new data. How can your model respond? How can your model respond on the new data? Understood, right? My question. First, you created y is equal to x square. Now, how can you hand over to the client in the production level? Next, client is saying that every month I will generate a new data. How can your model is respond? Now, next third question is, how can you monitor? We can say monitor or track your model performance. Tell me these three questions. That's it. I'm good. So this is your local. Everything is your local. But how can you answer this all questions? So that's where we coming MLOps, machine learning operations. Now see here, after model development, we need to ask some questions ourselves. First question is, how can we hand over a developed model to client? Which means, how can we deploy our model on production level? That is the first question. Valid question, right? This is a very valid question because your model is developed in a local system. In my computer, I developed, but how can I hand over to the client? This is a valid question. Now, how can we train our model again on the fresh data? Now, 1 lakh customers are coming in this month, April, and 2 lakh customers are coming in the June. Now, your model, your Python code should be generalized code, right? That code should train on the new data. So that is the next question. How can we train our model on fresh data in future on production level? Now, third question, how can we monitor or track our model performance? Now, this month, April month, 1 lakh customers are there. I created a model. Y is equal to x square is my model. My model performance is good. I am getting accuracy is equal to 90%. Now, after June, 2 lakhs customers are coming. Now, if your model is training on the fresh data, maybe your model is performance will drop, 70% will come. How can you monitor or track the model performance? So these are the all valid questions in the cloud environment when we are transferring into the client production level. So there, one more thing is called, how can we maintain the end-to-end flow from data ingestion to prediction? Like I told you, right? Data is there, ingestion, and you need to do prediction. So from here to here, there is the end-to-end flow is there. How can you maintain this end-to-end flow for client? So where to answer all above questions, our best practice is MLOps. Now see the scenario in the two ways, guys. One is developing a model is one way, and productionize the model is another way, production level. Okay, developed a model is a data science people will do. So to do the productions, ML engineering guy will do. ML engineering. Very simple. ML engineering. So I will tell you a beautiful thing now. In the AI world of AI roles, there are three kings are there. First one is the data engineer guy. What data engineer guy will do? Client will come, HDFC Bank will put some data into somewhere. Okay. Now the data engineer respond is, he need to ingest the data to make use of the data science. Okay, that is a data engineer guy. So I'm a data engineer. My response is what? HDFC Bank is giving a data to me. I want to put the data in the some cloud environment, some database or SQL, Microsoft SQL Server, so that data science guy can use the data. That is a data engineer guy. So this is the base level one. Now data is ready in the cloud. Data is ready in the database. Data is ready in the database. Okay. Then data science will come. So what this well guy do? He will understand the patterns and he will create a ML models. He will create a ML models. This is a data science guy. Now third guy is the ML engineer. What this guy's response is, he will make use of this ML model to the client in the production level. Client should use production level. So these all important people in the world of AI. Without these guys, data engineer, data scientist, and we can say ML engineer. So these three guys are very, very important. So maybe the model development doesn't know about this guy. Okay. The model development doesn't know about this guy. This guy knows model development. This guy know how to make into production. Okay. But as a good IT guy, we need to know about how the data science algorithms will work and how the ML engineering should work. Now, I hope you understood, right? The roles, how the roles are distinguished. Data engineer will ingest the data. Data scientist will do develop the model. ML engineer will do productionize the model. So this is the roles of in the three people. So you can say MLOps is a level 3. MLOps is a level 3. So I will just show you here for you make you easy. I will just write here. Step 1, ingest the data. Step 2, develop ML models. Step 3, make use the ML models in the production environment. The production environment. So this guy is a data engineer guy. This guy is a data science guy. And this guy is a ML engineer guy, MLE. So where our MLOps will come to here. MLOps will come to here. So data engineer guys plus data science guys will closely work each other. Closely work each other. Now data science guys plus ML engineering guys will closely work each other. Closely work each other. But they were ingesting a data. Ingest a data is a very hectic task. Okay, there are so many people will requirement here. Much people needed here. Much people needed here. In the same way, MLG engineering also much people required here. Because putting in the production level is not an easy task. Okay, so that's why always remember data science and MLG is a part. This both combination. If you know about data science and MLG, then you will be lead the industry. You can lead IIT easily. Data science and MLG. No, I hope you have some broad picture now. But I just want to repeat again. So we have started with our machine learning. What is about machine learning? And we know about types of machine learning. And we know about data science life cycle. And after model development, what is the questions you need to ask yourself? And then for to all these questions to answer, we go for MLOps. Okay. Now, good. How you till now you understood, right? Everything, the high level flow. Can I expect yes? Yeah, understood the high level flow. Yeah, the questions I will take. I will answer all the questions. Don't worry, guys, because this session is for you only. Okay, this section is especially we are set up for you only to clear all your high level doubts, clarifications. Yeah, Dhananjay, we'll take online or offline also both. Yeah, we will talk that at the end. Okay. Now, See, MLOps is the full form is called machine learning operations. That is clear. What is MLOps core function is machine learning is focused on machine learning models to the production. That only I'm telling, right? Machine learning models to the production. And then you need to maintain and you need to monitor. Very simple, guys. You need to put that in the production and monitor. So MLOps is a collaborative function. Often data scientist guys and DevOps guys. It's a combination. Thank God I am working some MLOps project. So even though I'm a data scientist, so that I know about end-to-end flow. So I very much thank to God because I have the opportunity to work with MLOps also. Because I don't want to stick as a guy with only I know models, I know the ingest, I want to know about end-to-end flow. You should be enthusiasm like that. So that's why we are here to teach you. Now, why we need MLOps? Now you already have an answer. Why you need MLOps? Because machine learning life cycle is a very complex life cycle. You need to ingest the data. You need to apply EDA. You need to do feature engineering. You need to do the model training. You need to about the model performance. You need to do the predictions. You need to deployment, monitoring, and you need to do the automated model training. That is, there's so many life cycles are there, but these life cycles are, trust me guys, you can enjoy this. You can enjoy literally. If you know about this data science and MLOps, you will enjoy the life. You only do the so much work because these all are R&D. These all are R&D. It is not like a daily routine task. It is not like a routine task. It is like a complete R&D, research and development. We are in that. So you know about why we need MLOps. Now this where is a very, very important thing, guys. MLOps end-to-end workflow. First two step is what? ML development. Next, ML development. You need to create a training operations. What is the training operations? I will tell you. So in ML development, after ML development, that means I can say ML development here. Step 1, ML development is there. What is ML development you will do? You will do data ingestion, you will do. Okay. Data ingestion you do. You will do data preparation, you will do. Now you should say the steps now. Okay. You will do data preparation, you will do EDA, and you will do model building, and you will do evaluation. These are all steps you do. Data ingestion, data preparation, EDA, model building, evaluation you will do. That's clear. This everything you will make one setup, guys. You will create a .py file, and some config file. Some config file. You will create some .py file, some config file. What is config file? I hope I can show you that. Give me 1 minute. Give me 1 minute, guys. I can show you the some config file. So this is a config file. You see, this is the config file I'm created. What is the Q&A maker cognitive services? What is the storage services? What is the autocomplete services? I'm creating some names so that I can use my Python code. Okay, don't worry about, don't panic about that. Okay, I'm just want to show you that what is the config files. Okay, what is your ID and how can you use that? What is your, suppose this, what is your container name? What is that? My name is landing. What is your storage account name? These all are some config files we are creating. So once you created your ML everything, you will create some .py file, some config file. So that is the step 1 you need to do. That is nothing but your training operations are ready. Why training operations are ready? The client is already said, every month he will get a new data. He will get a new data. How can you train that? You need to create a automated pipeline, right? You need to create an automated pipeline. That pipeline should do what? Data ingestion should do the component 1, component 2, component 3, component 4, component 5. These 5 components, you need to create a pipeline so that you can continuously train the model on new data. So this is, we can say, CT, continuous training. So that's why we need to create this .py files, config files. So you written data ingestion one function call, data preparation is another function call, EDA is another function call, model building is another function call, evaluation is another function call. Now total 5 function calls, all called 5 components. 5 components. You created a pipeline. And that pipeline, what it will do? Every time a new data will come, it will do the same task. Data ingestion, data preparation, ED, every time it will do. So this is the training operations, the code and config we will do. What it will do? Continuous training it will do. After training operations, what it will happen? Continuous training by using called training pipeline. So one training is done, you need to deploy your model by using called with register a model. And then we will do the model is deployed. What is the using? You need to serve, right? You need to prediction whether I can give the loan or not. When I can group the customers or not. Productions by using called serving package. And finally, you need to monitor that by using called serving logs. So these are the steps. Very simple. You know what is the first step? Model development. And second step, this is the heart. This is the heart of machine learning. Continuous training. Because new data is coming, I want to do the continuous training. After training is happened, I need to do the model deployment. After deployment is happening, I need to do the serve. Then I need to do the monitor. I will give one example here. You will understand with that example now. Suppose you want to send a courier to your friend. Okay, courier or package to your friend. You lives in Hyderabad. And your friend lives in Delhi. Your friend lives in Delhi. So understand, this example is very, very important, guys. What you will do? Step 1, what you will do? Tell me what you will do. You will go to the courier service. Courier service and register your name and courier. You will register this. Then step 2. So after register, what you will do? You will keep your package in the courier office. And step 3, they will give one tracking ID. They will give one tracking ID, so that you can track. Now step 4, think like that. This you want to send another package in next month. So what will happen? This month is package number 1, and next month is package number 2, and next month is package number 3. Some distinguish. Package number 1, package number 2, package number 3. Some distinguish will be there. Now step 5. Your friend should use end user. Your friend use that package. Friend use that package. So these are the life cycle, ma. These are the entire life cycle about the package thing. Now this we will opt our MLOps. Okay, ready with us. Now, important steps need to consider MLOps after model development. Your courier, you are going to the courier office and you are register your package. That means you developed a model, you want to register your model. That is called model registry. You register your package, then you are keeping your package in the courier office. I register my model. Next step is I want to deploy my model. Model deployment is the next step. Now you said, I want to repeat this task. That is the package number 1, package number 2, package number 3. Now on the new data is a model created, that is model number 1. In the next month, it's the model number 2. And next month is the model number 3. That is called model versioning. And you want to track your model, that is the performance. Model versioning is nothing but model 1.0, model 2.0. And finally, you want to end user. What is your use case finally? So this is a complete ML of steps, guys. Model registry, model deployment, model tracking, model versioning, model inference. So this is the complete ML of theory. I hope you understood that ML of theory. Okay. Model registry, model deployment, model tracking, model versioning. I will tell you how can we register the model. That is a practical we will see now. What happened to Chamanti Nalagoni? 1 minute, guys. Yeah, sorry, guys. Yeah, thank you. Now I hope you understood about MLOps and everything. Now go to the practical session. Okay, let's go to the practical session now. But again, with that, I'm repeating again what we have done. I'll just go to our slides, previous slides. The steps I need to do. Machine learning concept, types of machine learning, data science lifecycle, what is MLOps, why we use MLOps, and MLOps end-to-end flow. We have done this. Now with this, I hope you understood about machine learning. Those who already know, they can understand that. I know very well. Okay, but there are two types of guys, right? Those who already don't know about data science machine learning, I hope you already know about high level view. And those who already know about machine learning, you know about how MLOps is working. That is. Now with this, we will go for practical implementation. So for this practical implementation, I just want to use here Google Colab Notebook. Google Colab Notebook. Okay. Google Colab Notebook we want to use. That is why we use Google Colab Notebook. Why we use Google Colab Notebook. So Google Colab Notebook is a free service. Free service is offering the Google Notebook, Jupyter Notebook kind of it is. There are many two things, guys. One is if it is a huge big data will be available. If it is a huge big data will be available. Now Google Colab Notebook is offering from 25 GB data, 25 GB data, so that there is a huge data you can process. Also it can give one GPU access and TPU access. one GPU access and TPU access. And second one is MLOps generally is related to the cloud environment. Okay, generally it is a cloud environment. You want to register a model, right? You want to deploy a model, that we will use a cloud. So the cloud packages, installing cloud packages, installation is tricky when you in your local notebooks, in your local Jupyter notebook. So this is easy. This is easy in Google Colab notebook. I like this actually, because generally we usually work on the cloud packages. So when we install in the local, right, it is not at all installed properly. Okay, we need to create a virtual environments, and all these things we need to see. So that's why it is easy in the Google Colab notebook. So we'll open a Google Colab notebook now. Go to here. Just type Google Colab. Just type Google Colab. And then it is a, now it is a Google Colab. There's a new notebook option will be there. Click on the new notebook. Click on the new notebook. Now here in the top you see, right, Untitled 3:13. So I just want right here MLOps workflow. MLOps workflow. That is, I'm given a name here in the top. Okay, rename the notebook. So to work on the Google Colab notebook, guys, you need to connect here. There's an option, there is a connect is there. You need to internet. You need to connect this. That is a connection. It is a connecting. So it'll take some time, because due to internet issues or because of internet fast, it will go to that initialization and connect that. Now second step is you need to connect. Now it will give some RAM. How much RAM it is? 12.27 GB is there. Now I told you, right, we have one GPU and one TPU is there. Go to runtime. Now you have a change runtime type, and there is a GPU is there and TPU is there. There's a GPU is there and TPU is there. So if it is a big data, you can use that. If it is not big data, don't use that. That is not an issue. And you have file is there and code option is there, text option is there. The beauty of Google Colab notebook is it can work as a text, Word document. You can write some mathematics, you can write some images, and you can do the code also. That is the beauty of this. Okay. So GPU and TPU, actually, whenever you want to use that, right? Whenever the big data is there, to speed up the process, we have GPU and we have TPU is there. Okay. GPU and TPU. Like suppose you have a big data is there. Whenever you have a big data, you need to process very fast, right? Whenever you want to very fast, you want to process that. We have local, we have what? CPU will be available. In local, we have CPU will be available. Or like 4 CPUs or 3 CPUs you will have. But GPU is a graphical processing unit, generally will speed up your process. To load, suppose think like that, your data set has 10 lakh observation or 1 million observations. 1 million observations. To load 1 million observations, how much time it will take in local? How much time it will take in local? How much time it will take in Google Colab notebook? That is the thing. In Colab notebook, we have a GPU access and we have a TPU access, so that we can read very fast. It can read very fast. It will be very slow. So I can say CPU is the lowest level, GPU is highest level, and TPU is the very fast. TPU is the very fast. Okay. So if you want the CPU, this is, you can say GPU. I can give the name. TPU is nothing but tensor processing unit. GPU is nothing but graphical processing unit. And you know about CPU, right? What is CPU? Central processing unit. Central processing unit. Okay. Now we are going to here again. Now I want to do my MLOps here. I just want right here MLOps. Okay. I just write the notes also. That is the beauty. I like these Jupyter notebooks because you can write the story also. Not only story, like I can do the image also. Okay, I'm going to here suppose MLOps. So I'm just taking one image. Okay, I just want to show you this image. Which image I want to take? Okay, this image I will take. Now go to the inspect, and there's the image. Okay, the image is there, right? You're seeing that image. Go to the edit as HTML. Just copy this and come to here. Go to the text and paste this. See, image is coming now. That is the beauty. You can do the mathematics also like this. You can create the mathematics also. Okay. Now, step one is any package, any code if you want, right? You need to install a required packages. Install required packages. Install a required packages. Now, what is the packages we will use is we want to install some packages. So I will just display the packages names here. So here we will use a NumPy package and Pandas package and sklearn package and MLflow package. Okay. NumPy package used for what? Is a numerical Python. Numerical Python. It is used for mathematics. And Pandas package used for data frame and data analysis. sklearn package is used for machine learning algorithms. Now MLflow is our ML operations platform. MLOps platform. Now we'll see what is MLflow. I will just write here MLflow. So MLflow is a platform for machine learning lifecycle. Now it is a MLflow is look like this. In the few minutes you will get to know about what is this. The latest version is 2.2.2. It is a cloud package. We need to install this. So this is default. It will be there. Default Python. It will be there. No need to install. And here also this is Pandas. Also no need to install. And sklearn also no need to install. MLflow is a cloud package. We need to install this. Okay. MLflow is we need to install that. First, MLflow is there or not there. You just apply like this. exclamatory mark MLflow, exclamatory mark MLflow. If you run this, if it is installed, you will get some to see something. If it is not installed, you will see command not found. Okay, you will see command not found. So that means it is not installed. So we will install now. That is pip install MLflow. Simple. Pip install MLflow. Now just install this pip install MLflow. Now very good. It is installed. So what it is installed? Maco, Databricks, Docker, Git database, Git Python, and where is our MLflow? Here is MLflow. You see, right? Version is 2.2.2. Now the same thing we will run here. MLflow. It is installed now. So you will see something like this. Before what happened? If it is not installed, you will see command not found. After installation, you can see some information, right? This is good. Now next, if you want to see the version also. Now if you want to see the version, MLflow version. So the latest version is what? 2.2.2. Now the same thing we have seen here, 2.2. It is released in 14th March only. So MLOps is done. Now next thing is import required packages. I hope you clear the first point, right? Everyone, we install a package in the step 1. We install a package in the step 1. Now step 2. Step 2. What is that? Import required packages. Import required packages. First package is import numpy as np, import pandas as p. Now sklearn model. Now I want to give the information here. Now here I want to use a regression model. Okay, I want to use a regression model name called ElasticNet. The model name is what? ElasticNet model. This is a model name, guys. It is a regression model. You already know what is the regression model, right? Regression model is a supervised algorithm. That means we have input will be there and output will be there, but output is a numerical data. Output is numerical data. For this, we can use regression algorithms that you already know that is. So what model I want to use? I want to use a regression model. What is the name of the model? ElasticNet. So name of the model is ElasticNet. Data set I am taking is called wine quality data. Wine quality data. What is the data set name is called? Wine quality data. That means I will tell you, I will show the data set and I will tell you what is the wine quality data. And platform we are using Google Colab Notebook. Google Colab Notebook. And the objective is here is objective. What is your main target is? We need to predict the quality of the wine. So that is the data set name is called wine quality data. And the model name is called ElasticNet. This is clear. So now from sklearn, dot linear model import elastic net will come automatically. Yeah, elastic net, that is done. Next, from sklearn dot model selection import train test split. I will tell you what is the train test split. I will tell you. Next, I wanted to evaluate my model also, right? For that, from sklearn dot metrics import. These are some metrics. Mean absolute error, mean squared error, and some R2 score. Don't panic now. Okay, these are the some metrics. Those already know about regression analysis, they know very well. Those who don't know also don't need to panic. Once you learn, you will easily understand. Only thing is, this will give your model performance. Okay, if this will give your model performance, that's why we are saying what metrics. And this is a sklearn is the package. Inside we have a linear model. Inside we have a elastic net. Again, sklearn is the package. Inside we have a model selection, and we are importing train test split. I will tell you what is this train test split. Next one is import MLflow, and we can say import MLflow dot sklearn. So these are my packages. It is installed. Now step 2 is install the packages is done. We are good at step 2 also, right? We are good at step 2 also. Yeah. Now step 3. Step 3, read the data. Read the data. Step 3 is read the data. Now to read the data, there is a, if you see here, there's a file location is there, files. Just click on these files. Now you will see some arrow will be there. Whenever you click on the files, you will see some arrow. Now if you click on the arrow, I have some data sets will be there. Here I have wine quality red is there. I'm importing the data. So now the data is there, wine quality red. Again, I'm repeating, guys. We have some files location is there. Click on the files location. Click on the up arrow. It will redirect to your locations. Okay. Now inside we have one data set will be there. I uploaded that data. Now I will read my data. Now data equal to pd.read CSV. I need to provide the path inside. There the 3 dots will be there. Here there are 3 dots will be there. Go to here. There's a copy path will be available. Copy path. Now copy that and come to here. And now apply data.head. It will give top 5 rows. Now see, this is my data. Is this my data? Fixed acidity, volatile acidity, citric acid. These all are some chemical names. Now we have a target is what called quality is our target. Quality is our target variable, quality. So these all are input data sets, and this is our output column. It is a supervised learning and it is a regression problem. It is a supervised learning and it is a regression problem. As simple as that. Now just understand the data. What are the columns are there? Now see, first we'll understand how many rows and how many columns are there. That is give data.shape. So there are 1599 rows are there and 12 columns are there. What it will give the information? This data set has 1599 rows and 12 columns are there. 12 columns are there. So in that 12 columns, 11 columns are input columns. Input column, that is X. And one column, that is, what is the column name? Quality. What is the column name? Quality. Now quality is output column. Output, you can say target. Target column. We generally denoted by small y. Okay. So we have 1599 rows and 12 columns. In the 12, 11 columns are input columns and one column is called target column. Yes, very good. It is a regression problem because we have quality is numerical data. Okay, why it is a regression problem? Quality is a target output column. Output column has numerical data. Numerical data. So that's why it is called regression. Yes, very good. Numerical column. Now you got the points. Very good. That is excellent. Now data.shape. Now that is completed. Now you can see data.columns also in the quick way. So our interest is, we are not doing any EDI here. Our interest is to deploy model on the MLOps. What is our interest is? Our interest is model development and deployment. To develop a model, make sure we have all the columns have numerical data. Why numerical data? Mathematics, math works only on numbers. Only on numbers. So if any categorical data is there, we need to convert into numerical. So first we will check whether the numerical data is there or not. For that, data.info. We'll apply data.info. Now it will see all our types are float. No numerical, no categorical data, all are numerical data. We are good. And there's no null values also. See, all are non-null. It is a column number called fixed acidity. Number is 1599 rows. And it is a no null values. And data type is float 64. We are good. You can check this also. Data.isNull dot sum. If any null values is there, for the corresponding column wise, it will give the syntax. So we don't have any null values. So we are good. We don't have null values and we have the data is a numerical way. So we can create our model development. That is a step 4 now. Step 4. Step 4. Just write like this. Model development using MLflow. Now here I want to show you how the model development generally will happen. Okay. So step 1 is, this is a very, very important step, guys. We need to understand this is, okay, what I'm telling is now important. Everyone should understand. First, we divide data into two parts. One is train data, and another one is test data. Okay, we divide into two parts. One is train data and another is test data. And second is train data has input and output. Test data also has input and output. Again, we divide train data into input data and output data. Okay, input data and output. That means input column separately, output column separately. So that we can say X train and Y train. Simple. We divided input column separately and output column separately. And then the same way we divide test data into X test data and Y test data. First of all, train data divided into train data and test data, both having input columns and output columns. So we are separating into X train, Y train, X test and Y test. And then model development happens on train data. Model development will happen on train data. So next step is model development will happen train data. Then once your model is created, you need to test, right? So I want to model test. So I want to model predictions. Model predictions happens on X test data. So this will give Y predictions. Very simple, guys. I have created my model. Then I want to check my model is performed well or not. So I will pass X test on model. It will give some values. That is we are calling Y predictions. Finally, I will compare my Y predictions with Y test. Y predictions with Y test. So this is the entire flow. Now I just want to show you. Maybe for write up you will confuse, but I will show you now here how it will happen. Just see. Original data. Input columns are X1, X2, XP. Output column is Y. We divide into four parts. Train data, test data. Again, train data is X train, Y train. X test, Y test. What does that mean? Think like that. You have a data is like this. X is 1, 2, 3, 4. Y is 1, 4, 9, 16, 25. First step one is divide into two parts. Train data, test data. Then X train, Y train, X test, Y test. Now come here. This is the train data. First three observations is the train data. Last two observations are the test data. So it is a train data. X train, Y train. Test data is the last two observation. X test, Y test. Now my model is applied on which data? Train data. So I created a model called Y is equal to X square. Now I will pass 4 to the Y is equal to X square. I will get a prediction called 16. I will pass Y is equal to 5 to the X square. I will got the prediction as 25. So my predictions are what? 16 and 25. Now I will compare the 16 and 25. Already existed 16 and 25. So this is a comparison. So this is generally ML development flow will happen. I hope this is clear, right? Understanding this is very, very important, guys. Yeah. So you generally divide the data. That's it. You generally divide the data into two parts. That's the train data and test data. And again, X train and Y train. So to do all these things, we have train, test, split. English name, common sense English, common English name. Train, test, split. It is a sklearn package. What is this? sklearn package. So what I will do is I will divide my data into 70-30 ratio. 70-30 ratio. That means out of 159 observations of 70% is my train data. Okay. Out of 1599 observations, 30% is my test data. Now, and also I will divide train and test data randomly. I will divide randomly. That means the IDs how will be like 1, 2, 3, 4, 5, like this, so and so 1599 will be there. So I will divide the train data. I will pick first 5th observation. I will pick 10th observation. I will pick 500 observation. Randomly I will pick. Okay. Why will pick randomly? To avoid the bias. To avoid the bias. What is mean by bias? Suppose you are a fan of Virat Kohli. Okay. You are a fan of Virat Kohli. I will call you. I will ask you who is your favorite cricketer. What you will say? You will say Virat Kohli only. Suppose I pick a fan of Rohit Sharma, and I will ask you who is your fan? Rohit Sharma. You will say. So if I pick you the bias, this is the bias. If I pick the randomly, this output might be different. This output might be different. This output might be different. So consolidated, my model will give that good output. So that's why always divide the data randomly. Don't go with order. Okay. Fun 1 to 1000 is the train data, and 10012 1600 is the test data. This will give the bias. Don't go like this. First 1000 observation, pick randomly. Second 1600 observation, again pick randomly. So this we will do. What we will do? Divide data into 70-30 ratio and pick the observations in the randomly. Now we will do that. Okay. How we'll do that? Here. So train is one, test is another one. So I will apply train test split. Inside I need to pass my data and I need to pass my test size is equal to 0.3. What does this mean? We are dividing data into 70-30%. Now I will apply random state equal to, you can give any number, 1, 2, 3, 4, you can give 1, 2, you can give anything, you can give randomly, it will pick. Okay. Now train dot shape and test dot shape. Okay. Now see, out of 159 observations, 1119 observation is your train data, 480 observations are your test data. Now if I go for train dot head, now you'll see randomly it is picking. First observation is what? 642. Second observation 678. Third 412. Fourth one 73. Good, right? This is a great actually. We are dividing into 70-30 and we are applying random. So we got divided train data and test data. Now we need to divide X train and now divide data into X train X and train Y. input column, output column separately. We already know now train X equal to, out of these all the columns, if I remove this quality, remaining columns are what? Train data. Remaining columns are train data. So train dot drop. I'm dropping a column, quality. I'm dropping. So it is a column. So we need to give axis equal to 1. So that is the train data. In the same way, test data, test X. So test data dot drop, again same, quality, comma, axis equal to 1. So we divided input data. In the train data, we got the input data, and test also we got the input data. Now we get the output one. Train Y. So out of this train data, if I select only quality column, that is my output data. So train dot, now you can select only the quality. That's it. Now test Y is equal to test quality. Now that's it. We're done. Now you can check your train X dot shape and train Y dot shape. Out of 12 columns, 11 columns are input column and 1 column is what? Output column, right? See, total train observations are 1119. In that 11 columns are your train X and only 1 column is what? Train Y. In the same way, we have test X and test Y dot shape. 480 is 11, that the test data, and 1 column is the output data. So we divided train test split. Is that clear, right, till now? If random state is 0, instead of picking 642, it will pick another value. Okay. If you give another random state, it will give you. So how can you pass? Suppose I am giving 1 dot here. If 1 dot, how many lines can pass through 1 dot? Tell me, what is your answer? How many lines you can pass through 1 dot? Infinity. Yes. Like that, random state you can give any value. It can pick infinite times. Maybe after 642, it will come. After 412 will come. After 73 will come. 678 will come last. So whenever you change this value, the goal is fixed. It will pick the randomly, but the numbers will be different. That's all. Now we'll go to our main step. Now step 5th now. Start MLflow. Step 5th. Start MLflow. Start MLflow. Yeah, next. MLflow is a cloud algorithm. MLflow is what? MLflow is a cloud platform. Now what is my task? I want to develop a model. And I want to deploy on MLflow. Now Omkar created a model 1. He need to deploy on MLflow. Next, suppose Abhishek is created another model 1. Again, he need to deploy MLflow. Okay. Now this, yeah, random state. That is the random state is nothing but, again, I told you, right? It is a randomly it will pick that. Well, randomly it will pick that. That is a random state. Okay. I hope I given your answer already. Yeah, 1, 2, 3, 4. That only. If I given random state equal to 1, 2, 3, 4. Now tell me like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now randomly it will stop with 1. After that, how many combinations will come? Second letter. How many combinations second letter will come? How many combinations third letter will come? How many combinations fourth letter will come randomly? Many, right? So that many we will provide by using called random state. Random state. If you give random state equal to 1, it will give 1 order, 2, 3, 4, like 1, 1, 1, 1, 1, 1, 1, 1, like this. So whenever you change your random state, the numbers will be changed here. That's why I am explaining. Okay. Yeah. So next. So understand this is, guys, this start ML flow is very, very important. Now Omkar creates one model. He want to deploy an ML flow. Abhishek created one model. He wants to deploy an ML flow. That means what ML flow will do? ML flow will create some workspace for you, some workspace in the name of experiment. What is the name here? Name of experiment. Remember this. ML flow will create some workspace in the name of experiment. So first we need to create our experiment. What we'll do? First to create our experiment. So that is ML flow dot set experiment. Set experiment. I'm giving some path. My path is ML flow, and you are giving MLOps workspace. MLOps workspace. So this is my name. This is my workspace name. You can create your own workspace. Okay. You can give any name also. You can give NareshIT name also here. Okay. You can give your name also. That means you are setting a experiment. Why you are setting your experiment? There are thousands of people can create their model and they want to deploy an ML flow. ML flow should understand what is your experiment name, what is your workspace name. That ML flow should understand that. That's why we are creating a experiment name. Now this experiment is not there. So you see here, experiment with name ML flow, MLOps workspace does not exist. So we are creating, and this is your experiment ID, and this is the life stage is active, and artifact location. I will tell you what is the artifact location. It will go to this location. This is the location path. Okay. We'll just print some values. So print, I'll just copy this dot experiment ID. I'm just giving experiment ID. And again, I'm print this because I want to use that ID. So life cycle stage is active. Again, print. And you can give name also. So if I print all these three, now first one is my experiment ID name. This is my experiment ID. So now this is your ID. Now your workspace is active. What is your workspace name? ML flow, MLOps workspace. I hope this you clear now. Right? Can I get answer in the chat box? This is understanding is important. ML flow set experiment. Yeah, good. Now experiment is ready. Now we'll go to the code now. So I will create some function call because I want to write multiple times. So what I will do is I will create some function call. So def train model def train model is my function call name. So first step is what? Develop train test split. I want to divide my data that I already show you how to divide the data. So I will just copy from there because we already did that. So what I will do is I will take this. I'm taking this. This is I have done separately to make you understand, guys. Okay. This I have done separately to make you understand, because understanding that is very, very important. Now this is we have taken. So this is important. So I just removing this. I don't want this. Okay. Now your train model is done. Now second is initiate the ML flow now. Initiate ML flow now. So we are initiating now with ML flow dot start run. There is a start run is there. ML flow dot start run. Inside it is asking some experiment ID. You need to provide your experiment ID. What is your run name? Okay, you can give your run name also, and you can give a description also. So I'm providing my experiment ID. Experiment ID. What is my experiment ID? So this is my experiment ID, right? This is my experiment ID, comma, my run name. I want to provide run name also. That is, it is a regression. It is a regression. And I will provide the description also. It is a description also I want to provide. What is the description here? Anything you can write. Performing a regression analysis. So this all we can see UI now. MLflow UI, we can see this all. So this is the function call. So we are putting colons here and we are running this. Okay, experiment ID, run name and description. Now call ML model. Now call ML model. What is your ML model name? ML model name is called ElasticNet. So I can give LR equal to, I'm taking a variable name called LR because linear regression. So ElasticNet. So inside, what are the parameters are coming? Alpha is the one parameter and L1 ratio is another parameter. There are two parameters. One is alpha and another is L1 ratio. So I am giving alpha. Alpha is equal to some alpha I am providing, and L1 ratio equal to L1 ratio I'm providing. Because these are my parameters. I want to change these parameters every time I created a new model. Okay, mind it that I want to change these parameters. I am creating a new model. So L1 ratio. Why this is error is coming? Because these are the parameters we need to give in the function also. Alpha, comma L1 ratio. Now this will gone. Now ElasticNet is there. Now fit. Now develop your model. Model development on which data? Train data. So train X, comma train Y. This is your model is developed. So model creation is happened. Now what we'll do? Model prediction. Now model prediction. Model prediction will happen on which data? X test data. X test data, model prediction will be happen. So that is predicted data. Predicted data equal to LR dot predict. Because your model is, which name is there? LR. So LR dot predict. Which data you need to pass? Test X. So this is model prediction. Now be careful, guys. Just understand these three steps. First, train test split. Next, call the model. Next, fit the model. Next, model prediction. So next, what we will do? Model evaluation. Model evaluation. Now, model evaluation. What are your evaluation techniques you have taken? RMSE. This three: mean absolute error, mean square error, R2 square. So model evaluation will compare on which data? Which data? Model evaluation. Predictions versus test data. Predictions versus test data. So that we will do evaluation now. That we will do evaluation. So here RMSE equal to NP dot square root mean squared error bracket. You need to compare with your test y with the predicted data. Simple. Now RMSE is nothing but root mean square error, guys. RMSE is nothing but what? Root mean square error. I will tell you what is the root mean square error. So first error equal to your actual value, y actual value minus y predicted value. Okay. Suppose actual value is equal to 16 is there. Your model is predicted as 17. How much your error is getting? -1, like that. So this is error. Now we need to mean square error. So first we need to square this, and then we need to apply mean. Mean is nothing but summation of many observations. First observation, first error, error 1. Second observation, error 2. Third observation, error 3. So you need to combine all the errors. Error 1 plus error 2 plus error 3, and this we are squaring. Square 1, square 2, square 3. We are applying a mean. So this is called mean square error. The name itself what? Mean square error. If you apply the root, that is called RMSE. So this is a metric. Okay. I'm not going to about much deeper in that, because that is not our interest, right? I just want to give you a quick glance. What is RMSE? It is a root mean square error. That is a RMSE. Next, MAE. MAE is nothing but mean absolute error. These are the metrics. Mean absolute error. So again same test y, comma predicted data. Again R2 square. R2 is equal to R2 score of test y, comma predicted data. So this is the full plasma. So we are calling model prediction, model evaluation. Till now, is that clear, everyone? Yeah, Dhananjay. We will do that. I'm not coming to that way. Okay, we'll do that. Model register we will do. Okay, we are going step by step. Yeah, good. Now you need to log these parameters. What is the next step is important is I want to track my model parameters and model metrics and model name. So this is called we are registering. We want to register our models. We want to register our metrics. We want to register our parameters. So for that, what we will do is we need to go for here. We need to log that parameters. You can print also. While doing, you can print also. I'll just print this. Okay. Print RMSE, comma RMSE. Print MAE, comma MAE, sorry, comma MAE, and print that R2 score, comma R2 score, comma R2, sorry. So we are printing. Now next important is what? Log the metrics. Log the metrics, parameters and model on MLflow. Okay. So now MLflow dot log. Under the log, we have artifacts is there, metrics is there, params is there. Okay. So we are going for log param. So log param. On which name I want to log this? My name is alpha. Alpha is my name. I want to log alpha. Again, same. MLflow dot log param. What is the param now? L1 ratio. L1 ratio is my param. That is called L1 ratio. The parameters are completed. Now MLflow, now metrics. Now there are three metrics are there. MLflow dot log metric. Okay. What is the metric? First one, RMS is my metric name. Whatever you give here name, that will be visible, guys. If you give your name, that will be visible. Okay. So RMSE. And same thing I want to just copy here 2 times, but here is MAE and here MAE. And then here R2 square, that is equal to R2. Now this is done. Now I want to log what? I want to log my model also. MLflow dot sklearn. So we have already sklearn is there, right? Sklearn dot log model. What is that? Dot log model. What is your model name? Your model name is what? LR. What is your model name? LR. So my model name is called LR, comma. The name is called model. Now what is your register model? I want to register my model. So registered model name is equal to Elastic Net. My model name is called Elastic Net. Once you created your LR model, that will be under the model, it will register. We will see that now, how it will happen. Now I'm just running this. Okay. Now what are the two parameters taking? Alpha and L1 ratio. We are calling this train model. Okay. Now we are calling this. So I'm giving here suppose 0.3 and I'm giving here 0.2. I'm running this. Now see RMSE is this, MA is this. Now you see successfully model is registered with name what? Elastic Net. And what is the version? Version is 1. This is important to notice. What is your model name is called? Elastic Net. What is the version? Version is 1. Now, whenever you run, in the left side, there is a ML runs folder will be created. Okay. In the left side, ML runs folder will be created. If you click on the ML runs, there is your experiment ID will be there. If you notice, this is your experiment ID, guys. Okay, go to here. Check your experiment ID. Where is the experiment ID? See. So this experiment ID 56532, 56532, your experiment ID. Now here your models is there. In the model, there is a model name is what? Elastic Net. That you given, right? Elastic Net. That model you given here, Elastic Net. What is the version here? Only one version. Only one version is there. Now, if you click on the version, if you click on this meta.yaml, you will see what is the timestamp, what is the updated, What is the name? What is the run ID? This is the important. What is the run ID? With this run ID, if you go to your experiments, the same run IDs will be there here. See, same run ID. Now, if you go to the inside run ID, we have 5 things. One is artifacts, metrics, params, and tags. Metrics means what you log, RMSE, MAE, R2, that metrics will come to here. Now, what is the value? 0.51. See, 0.51 is your value. What is R2? 0.23 is your value. What is RMSE? 0.66 your value. This is a metrics. And what params you given? Alpha and L1 ratio, 0.3 and 0.2. So this is the artifacts. Artifacts is nothing but your model.pickle will be available. So your model now you can hand over to client by use called model.pickle. And to run this entire setup, what is your requirement.txt? I need MLflow this, cloud pickle, pathlib, sklearn, typing extension. So everything will be available here, guys. Okay, everything will be available here. So again, I'm repeating. So just see here, just notice this. So this is not the final thing. We need to show this in the MLflow UI. That is our ultimate goal. Okay. Now, see here. Whenever you created your MLflow workspace, they clearly say artifact location is content ML runs 32532. So whenever you run your code, it will create a ML runs. Inside it will create a experiment ID. Now inside you have run only one time, right? That's why one run ID is created. Suppose I have run second time. Now see the beauty here. Suppose I given a value is called 4. I given value is called 5. Now same name. That means I am running second time. Understood? The same name I am running second time. That means now version 2 should create, right? Now I run this. Now new run ID. Now new version is created. Version 2. Now you go here, just refresh this. Go to your models. Elastic Net is your name only one name. Under one name, how many versions is created now? 2 versions. Version 1, version 2. What is your version ID? What is your version ID? 72B. 72B is your version ID. Now go inside the experiment. Now you can see 72B is your one more ID. And all your metrics will be now here. Params, everything will be here. So this is how it will work MLflow. Now our main goal is we need to show this on MLflow UI. First of all, are you understand till now this? Yeah, yes, correct. Exactly. 2 metrics. We can use many metrics, Nani. Okay. Why we drop quality? We are not dropping. We are dropping and we are processing here. You see here. Okay, that is the overall story, right? I'm saying. While you are passing, you are creating your model. We are not dropping. You are passing your train X and train Y. Y is your quality only. Okay, ML models packages, Python packages will create such that you need to pass your input and output separately. That's why we are dropping. Okay. Now, everything we are logging, not only RMSE, MAE, there are so many metrics will be available. Once you learn about data science course, you will get to know that. Okay, next. Now you understand. Now what is our goal is MLflow UI. Now think like this. Now I want to go to the MLflow UI. So this is your Google Colab notebook. Okay, this is your Google Colab book. This is your MLflow platform. This is your MLflow UI. whatever you done, now you need to transfer here, right? To do this, we need to create some tunnel. What you need to create? A tunnel. Tunnel you need to create. Normal English name. Create. So to connect Google Colab to MLflow UI, we need to create a tunnel. What we need to create? Tunnel. So I will tell you what is the tunnel now. So now I will give all answers now at the end now, okay? Because we should not miss the flow. MLflow UI. To create MLflow UI from Google Colab notebook, we need to create a tunnel. And that tunnel name is called, ngrok. What is the name is called? Ngrok. Remember the name, ngrok. What is the name? Ngrok. What is ngrok? Ngrok is your tunnel. Who is created this way? The road. Okay, the company name. The company name is ngrok. What the company will do? It will create a tunnel from your local Colab notebook to your UI. That is called tunnel. Normal English name. It is a road. The road company name is called ngrok. Company name is what? Ngrok. Now we will pip install ngrok first. Okay, I need to install that ngrok. Now ngrok is installing. Ngrok is installing. Now ngrok is installed. Now what we will do is we'll try to create a tunnel. Create a tunnel now. Create a tunnel. We will create a tunnel. So pip install from py-ngrok import ngrok. Okay, py-ngrok. I think we need to install py-ngrok. I think not only ngrok, we need to install py-ngrok because ngrok is not working nowadays. Py-ngrok will work. Okay, ngrok, they are removing ngrok. Actually, they are calling that the py-ngrok. So py-ngrok. So next we need to create a tunnel. Tunnel ngrok. I will give a name called ngrok tunnel. I will give ngrok tunnel equal to ngrok dot connect. It is a UI, right? Whenever you want to connect a UI, we need to give some address also. That address generally people will give 5000 port. Okay, and prototype also we need to give, that is HTTP. So this is I don't need to explain because there is a UI. UI should be in our server. So that's why we are giving 5000 port in the HTTP. Now what we will do? We'll print a tracking URI, with the name of tracking URI. I want to track my ngrok underscore tunnel dot public URI. Anyone can access public URL. I'm just clicking this. Okay, very simple, guys. We are tunnel. This is a company. Company name is called ngrok. We are connecting with address 5000. I'm just clicking this. When I clicking this, what they are saying? Traffic was successfully tunneled to the ngrok agent, but agent failed to establish. Now we created a tunnel successfully, but this agent is not giving permission to create a UI. Why this agent is not given permission? Because you should not provide a authenticated ID. The agent doesn't know. The agent doesn't know your ID. So that's why he is not giving permission. permission. Simple, guys. First, what we are going? We are going to a company called ngrok to make a tunnel. From which place to which place? Google Colab Notebook to Google Colab Notebook to your MLflow UI. MLflow UI. So we created a tunnel, but the tunnel is not giving permission because we doesn't provide our ID. Now what we will do? We will provide our ID now. So get help with this error. Now it will reach to here. You just click on the login. Just click on the login now. When you log in, it will ask your email ID and it will create with omkar.nallagoni@gmail.com. Okay. Whenever you log in, it will ask your Gmail ID. We already have Gmail IDs open. That's why it is going directly. Now go into the your authentication. Go to the your authentication. Now this is your authentication ID. Okay, I just pass into the Google Colab Notebook. Okay, like this. I'm going to edit as HTML. I just copy this and just pasting in the Google Colab Notebook. And just paste here so that I can access from here only. So this is my ID. This is my ID. So this is my auth ID. So authentication ID, authentication token equal to, this is my auth ID. So I have given my authentication ID now. Now same thing I will take, okay? Same thing I am taking. If you have authentication ID, you no need to go to here, guys. Okay, no need to go to here. If you don't have authentication ID, first run this, then it will redirect to one place. It will redirect to one place. And then if you go to help, it will redirect to another place. Then log in, it will redirect to your omkar.nallagoni@gmail.com. From there, you will get authentication token directly copy. For every email ID, one authentication token will be available. One authentication token will be available. The Postman we can't use, Abhishek, here. That is a different case in the API testing. So this is creating a tunnels. Okay. Now, understood, right? If you have authentication token is there, don't go directly here. Directly you can write like this. So I'm creating this here. If already a tunnel is established, I want to kill the tunnel. So I want to do ngrok.kill. Already a tunnel is already existed. I am killing the tunnel. Okay. So this is, I can say, if any tunnels are there, if any open tunnels are there, close that. So for that, ngrok.kill. Now authentication token. Now set that ngrok.set auth token. Your auth token. What is your auth token? Authorization underscore token. I have set my token, my set. So I given my ID. When I given my ID, I can create the tunnel now. Simple. Step by step. Understand the steps. If any tunnels are there, kill the tunnels. Give your authentication token. Set your token and create the tunnel. Now tunnel is created. Okay. Now we'll click on this. When I click on this, now see there is no error. It is asking visit site. When it is asking visit site, this is we are success. We're good. So for that, we need to run MLflow UI. We need to run what? MLflow UI we need to run. So MLflow UI, whenever you run, and then you go to here, visit the site. When you visit the site, it will create a UI. See how beautifully the UI is now. Again, I'm repeating, guys. One, we provided authentication token. We run this. It will go ask the visit site. Once it is done, you need to run your MLflow UI. Until you work on this code will still run only. Now we'll check, just familiar with MLflow UI. What is your experiment ID? Tell me, what is your experiment ID name? What is your workspace name? What is your workspace name, guys? MLOps underscore something one, right? See, this is your workspace. MLflow, MLOps workspace. How many times you model do you run? 2 times you have run. One is 16 minutes ago, another is 12 minutes ago. What is your model name? One is first one version. 16 minutes ago you have run, that is a one version 1. 12 minutes ago you have run, that is version 2. Now if you click on place, you have metrics is there, your parameters is there. You can compare those also. Now first time when I run, that is 0.511 and second time 0.547. First time when I run 0.662, second time 0.694. This way is nothing but model tracking, model performance, model monitor. Okay, we'll go step by step again. This is MLflow workspace. Inside, how many times you create a run your model? 2 times. What is your run name? Regression is our run name. What is your metrics? We already logged all these metrics. Now I'm just clicking on regression. Now this is your run ID. This is your run ID. And model is registered here. Model is registered on 2023-04-16. What is the name of the model? ElasticNet. What is the version? Version is the V1. Now your model is registered. This is your model.pickle file. This is your AML file. AML file will give you what? What is the dependencies? What is the pip functions and everything. This is your ML model, everything. So if you download this, you can hand out to your client. He can run and he can get the output. That's some simple, that is. Okay. Now parameters under this run ID, what are the values? Under this run ID, what are the metrics? And what are your model, everything. That is your models, artifacts and everything. And they also given your prediction code also. You can directly call this one and you can do this. So we'll go step by step again. Okay. First step, go to your workspace. Understand this UI. How many times you have run? 2 times. What is your run name? Regression. What is your model name? ElasticNet. Go to your models. How many? What is your model name? ElasticNet. What is your latest version? Version 2. Click on this. How many times you have run? 2 times. That is version 1, another is version 2. So it is tracking version also. If you run one more time, it is version 3. It is version 3. Now, do you feel which version of model is good? Do you feel which version of model is good? Suppose Dhananjay is saying, sir, my version 1 model is good. Version 1 model is good. Suppose Abhishek is saying, my version model is good. My version model is good. Now, there's a 2 steps will be there, guys. One is staging and another one is production. Okay. Staging is nothing but what? Staging is nothing but it is a alpha version. Alpha version. Production is nothing but beta version. That means staging is nothing but it is on our local systems. It is internal use. Internal use. That means we are not giving to the client to that. Those models are in the production level that client can use. Okay. In outside industry, we have 2 things are there. One is staging will be there. Another one is production is there. I am thinking version 1 is a good model, that can go into the production level. So I'm agree with Dhananjay now. Dhananjay is saying that, sir, my version 1 model is good I want to set up into the production level. So for that, what we will use, we will go to the version 1. There is a stage will be there. Transition to staging, transition to production, or you don't want to use this model, go to archive. So version 1 is model is good. I want to use in the production. Then I am putting the production level. Now I'll go to my ElasticNet. I'm going to my models. Now my ElasticNet is my model name. What is my latest version? Version 2 is my latest version. But what is in the production? Production is the version 1 is there in the production. Now you think version 2 is in the staging. Now go to in the version 2, put in the staging environment. Now people will think like that. This version 2 is now in the staging level. Already version 1 is sending into the production level. So client can use the version 1 model, but version 2 is in the internal use only. Still development is going on. That is the meaning of staging level. This is the meaning of production level. And you can go to the experiments and you can get the version 2 model also from your workspace. This is a version 2 model. This is a run ID. This is a metrics. Everything will be there. So this is, we are logging. We are register the model. We are deploy the model. We are tracking the model. We are model versioning is happening. And finally, in next few minutes, we will inference the model also. We will see. So this is the beauty of MLOps, guys. Yes. Now I will give pass. You can ask me if any doubts. Thank you, Abhishek. You can put in the chat. Because we are almost completed this and only the inferencing is there. I will show you the inference also now. If you want PPDs, MLOps is third-party server provider. Exactly, Rajwal. MLOps, you know, the beauty of this, how it is. Only 3 guys are ruling here. Okay. Only 3 guys in the world. One is GCP. One is AWS. One is Azure. Okay. Now what we'll do, I'm working with Accenture, right? So-called Accenture or TCS or Infosys, we don't have any cloud setup, right? We don't have any cloud setup. What we will do, we will pay the money to, either GCP service, either AWS service or Azure service. So they will offer this MLOps platform or AutoML, so-called like this. They will perform like this. So MLOps, now Databricks is there. That is also you can use. MLOps is tie up with so many companies. MLflow like that. So every new data we need to work on the lower environment once we test in the stage. Exactly, Venkat. That is the correct. But we need to create some pipelines. Okay, you will not create automatically. You will, every time you should not go. You should not create. You will create some pipelines. How the pipelines will be there? Data ingestion, and then data pre-processing, and data EDA. Now EDA is the very biggest task, right? In the EDA, there are so many subtasks will be there. Feature selection will be there. Feature engineering will be there. So many things will be there. And then we'll deploy a models. And then you log entire everything. Yeah. That is the GitHub Actions is important. Now I developer, suppose in my team, 5 members are there. Okay. 5 members are there. I have worked on model development. Okay. You are working on EDA. Okay. Some other person is working on data ingestion. We all created .py files only. .py. It is also .py file only. This is also .py file only. Now this is all .py file. Now there is a GitHub is there. Now you will push your code in the GitHub or DevOps, whatever it is. You will push your code in the GitHub. And this guy also put your code in the GitHub. There's a one guy is there, DevOps guy. There's a one guy is the DevOps guy. What he will do? He will consolidate our codes, and he will trigger the pipeline so that codes can be updated. Once codes can be updated with new code, your pipeline tree will trigger. Your ML flow will be trigger. So that is called Git actions. That is also we will learn in our Naresh IT. So new data never go directly to the prod. No, never. Prod is production level. Client should use. Client will ask many questions. you know, right? How many client will ask the questions? They never understand anything, but we need to explain to them everything. So never goes directly. Actually, nowadays, what is happening, right? So I am working a company called Makasen. Okay, now Makasen. So we are developing some ML models to the Makasen. We are developing some ML models. Now the Makasen, the data they are getting from PwC. That means PwC is responding for data. They will give the Makasen. Now Makasen give to the Accenture. Now data engineering guys will do the data ingestion. Now data science will guide to the model development. Now ML engineering guy will do the MLOps. Now data engine science and ML both are same. They are doing the same task nowadays. Now these guys always talk with PwC data. Now these guys will say explain to the Makasen how it is happening and everything like that. Yeah, Roshan, you can contact with admin. We are starting that MLOps batch. So once client everyone certified stage, we'll push the product. Correct, Venkat. You're absolutely correct. How our model do EDA automatically? Yeah, we need to create some pipelines, Dhananjay. Okay. This you need to contact with admin, Rajbal. Okay. Yeah, we'll create a pipelines, Dhananjay. So it is not who are those completed data science. So we can data science. It is good for to data science also. If you know the good to data science, then you can that. Or you can call to our Naresh IT. We will give a clear guidance on this. Actually, we have one more step is there, guys. Okay, wait for last minute. Okay, we have one more step is there. What is our one more step? We need to do the predictions. Just copy this. Okay, I'm just stopping this now. Okay. Now, this is my model. This is my model. Which model? Version 2 model. I'm loading my model. I want to pass my test X. Then I will get my outputs. These are my outputs. If any new data will come, they'll directly pass here and they will get the output. As simple as that. Because this is a free version, that's why we are stopping and we are running and we are going and checking. There's a paid versions will be there actually. If you pay that, then you can do automatically that thing. If this is a paid version, is not a paid version, that's why we are stopping here. When you stop, your ML flow will gone. Thus UI will gone. So that is a simple drawback here because we are using a free version, right? That's why. So now this is the end-to-end ML flow, guys. I hope you understood the everything flow. Okay, I hope that we have a very good session. We have very good session. You understand some extent you understood how the life cycle, how the data science life cycle will happen. So I'm expecting that. You can say that in the chat also. Need to deep dive more. Yeah. This is a simple task, guys. Workshop is not like that. Workshop is not like that. It is a simple, like it is a first task, so that in the going on we can do more tasks also. That is. But what we learn? What is ML? We learn. And next, types of ML we learn. And we learn data science life cycle we learn. And we have seen some good examples also. Why we need MLOps, end-to-end flow of MLOps. And we learn about practical implementation. Practical implementation using MLflow. MLflow. So we covered many things. Yeah. Yeah. If any course related, because I am a trainer, right? That any course related, okay, enrollments and everything, the admin guy is there at Naresh IT. So admin guys are they are cooperative. They will explain each and everything for you. You can contact to direct Naresh IT. We always try to give the best teaching and best concepts to you. We always. Yes, definitely, Pavan. Because data science people know only what? You know, only to create models, right? Yeah, Kubeflow, Docker, Kubernetes, TFX, everything. You're correct. Airflow, Kubeflow, everything will be there. You're right. Yes, the cloud. Any specific cloud, we use GCP. GCP, we can do that AWS or Azure Databricks. We'll do that. See, Subbu, what is happening, right? I can say AWS, Azure, and everything is like a mobile phone. Okay. If you know one thing, you can know other easily. If you know GCP, no one can teach for Azure also. You can easily know Azure also. Only the things like a Realme phone and iPhone and Samsung phone. That's all. Okay. Yeah, MLOps using TensorFlow. That's the TFX and Kubeflow and MLflow is all MLOps. Yes, Roshan, you're right. Yes, all sessions are hands-on only. MLOps means hands-on. That's it. So that you need to contact with. Yes, we'll cover all these things. Yeah, batch and duration, everything. Please contact to admin. I hope you have a good session. So we are always here to provide a best teaching facility to you. Yeah, you can contact everything with admin. They will give a best support to you. I hope you enjoyed the session, guys. Yeah. Please say yes. Yeah. Thank you. Thank you so much, guys. Bye. Take care. We'll see you.